The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. So today we're going to be reviewing for the Chapter 7 test, which is tomorrow. I want to remind you of a few things. So tomorrow there'll be no Zoom meeting during class time. I'll be here in the afternoon for my office hour, but basically anytime today on into tomorrow night, 11:59 p.m., you need to take and complete your Chapter 7 test. I also want to remind you of a few other things. It's great that some of you are emailing me requests for doing problems during the Zoom session. I'm happy to do that. However, could you please try and get them to me before 10 a.m. in the morning? I happen to have time between classes today, and there were quite a few that were there that weren't there at 10, but I don't always have time after 10 a.m. because I have another class. So if you could get those to me earlier. Also, it would be helpful if you'd tell me what section. I'll get a student that'll say, yeah, could you do problem number 7? And I'm like, which number 7? From the review, from 7.7? That would just be really helpful if you could do all that. Anyway, enough whining on my part. Let's get started. So first of all, as I said, I've got quite a few questions that people asked about. So we'll take a look at those. And then if there's any other questions, we'll deal with those as well. So this is from section 7.6, number 13. It says solve the equation and check the result. Enter your answers as a comma separated list. If there is no solution, enter no solution. I also want to mention that one person just requested for me to talk about finding the least common denominator. So I'm going to be doing that as usual throughout all the problems that that pertains to. So here's the first problem. It says 8x divided by x squared plus 2x minus 15 plus 5 over x plus 5 equals 1. So we have an equation that contains fractions. The thing we want to do first of all is to clear those fractions using the least common denominator. To find the least common denominator, we need to factor each denominator. So doing that, I'm going to get 8x over, let's see, x and plus 5 and minus 3 plus 5 over x plus 5 equals 1. So I factored this denominator into x plus 5 times x minus 3. Now, the LCD is the product of the highest power of each different prime factor within any single denominator of our problem. So what do we have? We have x plus 5 to the 1 power. And over here we have x plus 5 to the 1 power. So the highest power of x plus 5 is just x plus 5 to the 1 power. We don't put them together. We just take whichever one's highest. In the case of a tie, we can take either one. Next, I have x minus 3 as a prime factor. And that's it. So there is my least common denominator. Any questions from people here how I got that? All right. So now I'm going to multiply both, whoops, let me put that in the right place here. Both sides of the equation by the LCD. Okay, I'm going to distribute. So here, and then here, and then we'll just multiply this all together. All right. So I'm going to get x plus 5 times x minus 3 times 8x over x plus 5 times x minus 3. So that's this. Then plus x plus 5 times x minus 3 times 5 over x plus 5 equals x plus 5 times x minus 3 times 1. So distributing the least common denominator, I get that. Any questions there? Okay, so now doing this multiplication, the x plus 5s and the x minus 3s would all reduce down to 1 over 1, and I'm left with 8x. Plus the second product, x plus 5s reduce out to 1 over 1, and I'm left with x minus 3 times 5, which is going to be plus 5x minus 15. On the right side, x plus 5 times x minus 3 times 1 is going to be x plus 5 times x minus 3, right? So we can get rid of the times 1. And foiling this out, we get x squared minus 3x plus 5x minus 15. Combining like terms, on the left side, I get 13x minus 15. On the right side, I get x squared plus 2x minus 15. Well, I've simplified each side of the equation as much as I can. I see that it's a second degree equation, so I'm going to put everything on the right so that my leading term x squared is positive. So my next step is going to be to subtract 13x and add 15. I now get 0 equals x squared minus 11x. And then this constants cancel out. Okay. Now, if I factor that, I get, let's see, maybe I can fit it in over here. I get 0 equals x times x minus 11, taking out the greatest common factor. So now I get x equals 0 or x minus 11 equals 0. Let's see here. If x equals 0, then x equals 0. If x minus 11 equals 0, adding 11 to both sides, we get x equals 11. So x equals 0 and x equals 11. It says, enter your answers as a comma-separated list. So be sure to separate them with a comma. Sometimes people accidentally push the period button and then it marks it wrong because it doesn't know what you're doing there. All right, we good to go on number 13. Any questions? Okay. This is number 27, again from 7.6. Let's see here. That's what they wanted. All right. Solve the equation and check the result. If the equation has no solution, so indicate. 1 over, oh, excuse me, messed up already. 1 minus 2 over b equals negative 3b over b squared plus 2b. So again, to clear the fractions, I need to find the least common denominator. To find the least common denominator, I need to factor each denominator. So I get 1 minus 2b equals negative 3b over b times b plus 2. So taking out the greatest common factor there, we get b times b plus 2. So now the LCD is what? B times b plus 2, because I have b to the first power, b to the first power, they're a tie, so the highest power would just be either one, b to the 1 power, and then b to the, or b plus 2 to the 1 power. So there's my LCD. Okay. Now I'm going to multiply both sides of the equation by the LCD. And I'm going to distribute here and here, and then multiply there. Okay. So I get b times b plus 2 times 1, that's this thing, minus b times b plus 2 times 2 over b. And notice this minus sign went right there. Okay. Let's make that a little more legible. Equals b times b plus 2 times negative 3b over b times b plus 2. Okay. So now going back and distributing and reducing and all that good stuff. Let's see here. B times b plus 2 times 1 would be the same thing as b times b plus 2, right? Which is going to be b squared plus 2b. Minus, in this case, I could reduce out the b over b to 1 over 1. And I now have what? B plus 2 times 2. Oh, but I've got to be careful here because I'm subtracting that whole thing, which is what? 2b plus 4? So 2b plus 4, that whole thing is going to be subtracted. Oh, that's kind of tricky there. Equals. So what have I got here? I've got b squared plus 2b minus 2b minus 4, which is b squared minus 4. Okay. On the right side, the b's reduce out and the b plus 2's reduce out, and I've got minus 3b. So I'm going to add 3b to both sides, and I get b squared minus, plus 3b minus 4 equals 0. Factoring that, I get a b and a plus 4 and a minus 1. Taking each factor and setting it equal to 0, b plus 4 equals 0, b minus 1 equals 0. So subtracting 4 from both sides there, adding 1 to both sides there. So b is negative 4 and b equals 1. And we're back there again if anybody needs to see that further. Okay. That takes care of that student. So give me a minute here to switch so that I can look at other students' problems. Let's see, 4,400. Seven. Number 6. All right, we good to go on? I'll take that as a yes. This is from section 7.7, number 6. It says, solve the number problem. In fact, I'm going to go ahead and just show this screen for a minute. So I'll read it, but just so that you can see what it is. The sum of a number and its reciprocal is 53 over 14. Find the number and its reciprocal. Okay. The sum of a number and its reciprocal is 53 over 14. Find the number and its reciprocal. Okay. So how about if we call the number x? What would its reciprocal be? Its reciprocal would be 1 over x, right? The reciprocal of x would be 1 over x. So the sum of a number and its reciprocal is 53/14. Find the number. So there's our equation. Any questions there? Okay. So now we have an equation containing fractions. The LCD would be what? 14 times x. Everybody okay with that? We're going to multiply both sides by 14x, distributing here and multiplying there. 14x times x is 14x squared. Then we get 14x times 1 over x, which is going to be what? 14. And over here on the right, the 14s reduce out and we get 53x. So 14x squared plus 14 equals 53x. Okay. 14x squared plus 14 equals 53x. So we're going to subtract 53x from both sides. 14x squared minus 53x plus 14 equals 0. That doesn't look friendly at all, does it? Well, let's hope I didn't make a mistake. Here we go. 14x squared minus 53x plus 14 equals 0. So A is 14, B is negative 53, C is 14, the product. See, 14 times 14, I think that's 196, but let's check. 14 squared is 196, and the sum is negative 53. So both my numbers need to be negative. Okay. So let's see. I could try negative 196 and negative 1. That would give me negative 197 as a sum. I could cut this one in half, which would be negative, what, 98, and negative 2, which would be negative 100. I could cut the first one in half, negative 49 and negative 4, which would be negative, that wasn't so bad, was it? Okay, so there's our two numbers. So we've got 14x squared minus 49x minus 4x plus 14 equals 0. Factoring by grouping, greatest common factor 7x, leftovers 2x minus 7, leftovers 2x minus 7, and a minus 2 outside. So I get 2x minus 7 times 7x minus 2 equals 0. Take each factor that contains a variable, set it equal to 0 and solve it. Negative, or 2x minus 7 equals 0. 7x minus 2 equals 0. Here we're going to add 7 to both sides. 2x equals 7. Divide by 2, x equals 7 halves. Here we're going to add 2 to both sides. 7x equals 2. Divide both sides by 7. X equals 2 sevenths. Okay, so I've got two possible answers. X could be 7 halves, that is the number, or x could be 2 sevenths. Well, let's go back to our original problem. So we've got x is 7 halves, x is 2 sevenths. They actually both work, because consider this. If x is 7 halves, what would its reciprocal be? 2 sevenths. If x is 2 sevenths, what would its reciprocal be? 7 halves. So basically, one of the numbers is 7 halves and one of the numbers is 2 sevenths. But in the directions, it said smaller value, larger value. So let me go back to the screen that had the answers on it. So here, the smaller value would be the 2 sevenths. The larger value would be the 7 halves. So make sure that you read and follow the directions there in terms of putting in your answer. All right. Any questions about that? Okay. Let's see. Make sure I'm sharing. Oops. The screen again. And we need. Okay. Another student. This is 7.7. Starting with number 4. Okay. So let me show you the problem. Solve the number problem. This is number 4. If the denominator of 9/16 is increased by a number and the numerator of the fraction is doubled, the result is 1. Find the number. Okay. So we've got this fraction, 9/16. It says if the denominator is increased by a number, so we're going to add a number to the denominator, and the numerator of the fraction is doubled, so we're going to multiply the numerator by 2. The result is 1. So basically, I could clean that up a little bit and say 18 over 16 plus x equals 1, because 9 times 2 is 18. Okay, so I have an equation containing a fraction. The least common denominator is 16 plus x, or x plus 16. So let's multiply both sides by 16 plus x. On the left side of the equation, the 16 plus x is reduced down to 1 over 1, and I have 18. On the right side of the equation, 1 times 16 is 16, and 1 times x is x. Solving for x, subtracting 16, I get x equals 2. So find the number. The number is 2. Consider this, if we put it right there, 9 times 2 is 18, 16 plus 2 is 18, 18 over 18 equals 1. So it checks. Any questions there? Okay, we're going to take a look at number 5. And again, let me show it to you here, just so if you go back to look at it later, you'll see what the problem looks like. If a number is added to the numerator of 3/4 and twice the number is added to the denominator, the result is 4/7. So we're to find the number. Find the number, and we'll call it x. If a number is added to the numerator of 3/4 and twice the number is added to the denominator, so that the result is 4/7. So we're adding x to the numerator and 2x to the denominator. All right. So again, we have an equation containing fractions. The LCD would be what? 7 times 4 plus 2x. Now, I could factor 4 plus 2x into 2 times 2 plus x. Okay. And then my factors would be 7 times 2 times 2 plus x. You know, I should do that to be consistent. So let's do that. Hang on. So this becomes 3 plus x over 2 times 2 plus x equals 4/7. Okay. So my LCD is 2 times 7 times 2 plus x, or 14 times 2 plus x. Okay. I'm going to multiply both sides by 14 times 2 plus x. 14 times 2 plus x. On the left side, the 2 plus x's cross out, and the 14 over 2 reduces down to 7 over 1. So I now have 7 times the quantity 3 plus x on the left side, which I could go further and get 21 plus 7x. On the right side of the equation, 14 over 7 is 2 over 1. 4 times 2 is 8. So I've got 8 times 2 plus x, or 16 plus 8x. I'm going to solve for x on the right side. So I'm going to subtract 7x from both sides. 21 equals 16 plus x. Subtract 16, 5 equals x. So the number is 5. Let's check it. 3 plus 5 would be 8. 4 plus 2 times 5 would be 4 plus 10 would be 14. Does 8 over 14 reduce down to 4 over 7? Yes, it does. Okay. Now we've got number 6. More number problems. The sum of a number and its reciprocal is 97 over 36. Find the number and its reciprocal. So this is going to be a lot like, I guess it was a different student that asked this question. Okay. So we'll call the number x, and its reciprocal will be 1 over x. So the sum of a number and its reciprocal is 97 over 36. The LCD is 36x. We'll multiply both sides by 36x. Distribute, distribute, multiply. I get 36 times x plus 36x, 36x squared, excuse me, plus 36x times 1 over x equals 97x. Okay, 36x squared. So we get 36x squared plus the x is reduced down, 36 equals 97x. Okay, I'm going to subtract 97x from both sides. 36x squared minus 97x plus 36 equals 0. I'm going to take that and write that on the next page. 3697. So 36x squared minus 97x plus 36 equals 0. So A is 36, B is negative 97, C is 36. The product is, I have no idea, but I'm going to come back and find it here in a minute. The sum is negative 97. 36 times 36. Let's see, 36 squared, 1296. 1296. Wow, I can see why somebody asked about this problem. Okay, so a positive product, negative sum, two negative numbers. So product, sum, how about negative 1296 and negative 1 as the product? The sum would be negative 1297.
Because I've been trying to do it when you did the other example, I got negative 81 and negative 16.
Oh, okay. Negative 81 and negative 16. First of all, let's verify, and we would have gotten there, but if we take negative 81 times negative 16, helps if you turn your calculator on. Whoops. That would give me a sum of negative 97. Excellent. Saved me. You just didn't want to have to listen to me for 5 minutes drone on about finding it, did you?
Well, it took me a while to find it as you were doing the other problem. So
I'm just kidding. You cut that in half, double it, cut it in half, double it, eventually you'd get there. Good job. So you got 36x squared. I'm just kidding you. All right. Minus 81x minus 16x plus 36 equals 0. Split it down the middle. Oh, I'm thinking that's going to be a 9x and then a 4x minus 9 and a 4x minus 9 and a -4. So we get 4x minus 9, 9x minus 4 equals 0. So 4x minus 9 equals 0, 9x minus 4 equals 0. Add 9 to both sides here. 4x is 9. Divide by 4, x is 9/4. Add 4 to both sides here. 9x is 4. Divide by 9, x is 4/9. And you get the same scenario we got in that other problem, where if x is 9/4, its reciprocal is 4/9. If x is 4/9, its reciprocal is 9/4. So x is 4/9 and 9/4. And again, it said to write the smaller value first. Okay. We've got one more of these number problems. I know you're thinking, please, something else. We'll get there. 7.7, number 8. Come on here. My mouse keeps escaping from me. All right, if the same number is added to both the numerator and denominator of the first measurement, the result is the second. So the first measurement, okay, so what do we got there? We've got, this whole thing's an inch. Each one of these little hash marks is 1/16 of an inch. So the first measurement is 1/16, and the second one is 1, 2, 3, 4, 5, 6/16 or 3/8. So I'm going to say first measure is 1/16, second measure is 6/16 or 3/8. Okay. If the same number is added to both the numerator and denominator of the first measurement, the result is the second measurement. So the first measurement was 1/16. We're going to add the same number to the numerator and the denominator. And the result is going to be the second measurement, which is 3/8. Okay. So we have an equation. The LCD is 8 times the quantity 16 plus x. So I'm going to multiply both sides by 8 times 16 plus x. 8 times 16. 16 plus x. So on the left, let's see, these are going to cross out, and we're going to have 8 times 1 plus x, which is going to be 8 plus 8x, distributing. On the right, the 8s are going to cross out, and we're going to have 48 plus 3x. Okay. I'm going to solve for x on the left. I'll subtract 3x from both sides. 8 plus 5x equals 48. Subtract 8 from both sides. 5x equals 40. Divide by 5, x equals 8. Let's see if that's true. If x is 8, we'd have 1 plus 8, which would be 9. Over 16 plus 8, which would be 24. 9 over 24, divide the top and the bottom both by 3, and you get 3/8. It checks. Okay. And let's see here, number 12 coming up. When a plane flies downwind, the wind pushes the plane so that its speed is the sum of the plane in still air and the speed of the wind, okay? So if you're going downwind, you've got the plane speed plus the wind is pushing it. Traveling upwind, the wind pushes against the plane, so its speed is the difference of the speed of the plane in still air and the speed of the wind. So again, going downwind, the wind is helping the speed of the plane. Upwind, the wind is hurting the speed of the plane. There's a song, old song by a guy named Bob Seger, Running Against the Wind, and it's all about, life sucks and then you die kind of thing. Everybody's against him, everything's against him, he's running against the wind. Where like if you go with the flow, what does that mean? Taking the easy way. So you're going with the wind or with whatever force. All right. So it says using the table, find the speed of the wind. Okay. So most of our work is already done for us here, but let's take a look at what we're going to do here. I'm going to copy this table. And then we'll take a look. So I've got downwind, upwind, and rate times time equals distance. And this is 245 plus x, 245 minus x, 290, 200, and then t and t. Okay, so come on here. So here's the table. So the plane is traveling 245 miles per hour on its own. Okay. If the speed of the wind is x, then going downwind, it's going to be added to it. Going upwind, it's going to be subtracted from it. The time is the same in both cases. Okay. Let's see here. Yeah, in the problem it said, suppose the plane travels 245 miles per hour and still air can travel 290 miles downwind in the same time. Okay, so what we're going to do is we're going to replace the times knowing that they are equal. Okay. If distance equals rate times time, we divide both sides by rate. Time equals distance divided by rate. So time equals distance divided by rate. This would be 290 over 245 plus x. This would be 200 over 245 minus x. So our equation becomes 290 over 245 plus x equals 200 over 245 minus x. Okay. Any questions there? So our LCD is going to be what? 245 plus x times 245 minus x. So 245 plus x, 245 minus x, 245 plus x, 245 minus x. So over here, the 245 plus x's are going to reduce out, and I'm going to have 290 times 245 minus x. On the right side, the 245 minus x's are going to reduce out. I'm going to have 200 times 245 plus x. Okay. So distributing, let's see here, what do we got? 290 times 245 is 71,050 minus 290x equals 200 times 245, 49,000 plus 200x. I'm going to solve for x on the right. So I'm going to add 290x to both sides. That's going to give me 71,050 equals 49,000 plus what? 490x. Subtract 49,000 from both sides. So let's see. 71,050 minus 49,000. We get 22,050 equals 490x. Let's divide both sides by 490. And we get x is 45. So that would be 45 miles per hour. And going back and looking at our problem in WebAssign, we see that there is the correct answer. Okay. Let's see here. Next person. Okay. Let's see. Five. Here. This is from the chapter review. Seven. Number 8. Okay. More number problems. So let's find the mouse. So this is from chapter 7, review number 7. If a number is subtracted from the denominator of 4/5 and twice as much as added to the numerator, the result is 5. Find the number. Okay. So our fraction is 4/5. If a number is subtracted from the denominator, so I'm going to subtract x from 5, and twice as much as added to the numerator, so I'm going to add 2x to the numerator, the result is 5. Okay. Well, the LCD here is what? 5 minus x. So we'll multiply by 5 minus x on both sides. Here, those reduce out. We get 4 plus 2x equals 25. Slow down. 25 minus 5x. So we're going to add 5x to both sides. Subtract 4 from both sides. Divide by 7. X equals 3. Let's see. 4 plus 2 times 3 would be 4 plus 6 is 10. 10 over 5 minus 3. 10 over 2 is 5. 5 equals 5. So the number is 3. And finally, number 8. So let's take a look at that. It says, a woman can bicycle 40 miles in the same time that it takes her to jog 10 miles. If she can ride 15 miles per hour faster than she can jog, how fast can she jog? All right, so we're talking distance, rate, time. So I'm going to make a chart here. Distance equals rate times time. I know you can't see my chart yet, just a minute. So we've got bike and jog. Okay. A woman can bicycle 40 miles, so 40 miles, in the same time, also the times are the same, as it takes her to jog 10 miles. If she can ride 15 miles an hour faster than she can jog, so if the jogging is R, the bike is R plus 15, how fast can she jog? Okay, so we've got the distances, the rates, we know the times are equal. Distance equals rate times time, divide both sides by rate, time equals distance over rate. So the first time would be the distance, 40 over the rate, R plus 15. The second time would be the distance, 10 over R. So our equation becomes 40 over R plus 15 equals 10 over R. The LCD in this case is going to be R times r plus 15. Keep in mind, even though this is an r and this is an r, this r can't appear as a factor by itself because of the plus 15. So that's why we need them both. On the left, whoops, still in the eraser mode. On the left, the r plus 15s reduce out and we have 40r. On the right, the r's reduce out and we have 10r plus 150. Subtract 10r from both sides. 30r equals 150. R equals 5. So she jogs 5 and she rides 20, and it said, how fast can she jog? So it'd be 5 miles per hour. Okay. And I've gone through a bunch of LCDs, so I hope the person that asked about that saw enough. We've got 4 minutes left. Anything for the good of the order? Anything, other questions you want to look at?
Could we possibly
Help
do
with
number 6?
4 and 6.
Okay, we've got bunches more, huh? Okay, who asked for 4?
I need 4.
Okay, so let me get yours. Okay. Okay. Come on. This is on the chapter review.
Yeah.
Number 4. Okay. So this is the chapter review number 4. It says multiply and simplify if possible. Okay. So we've got x squared plus x over 3x minus 18 times 12x minus 72 over x squared plus x plus 2x, excuse me, plus 1. Okay, we're going to factor everything. I can take out an x on top. I can take out a 3 on the bottom. I can take out a 12 on the top. I can factor this into x plus 1 times x plus 1 on the bottom. Okay, so far so good? Lindsay?
Yeah.
Now I can reduce out the x plus 6's. One of the x plus 1's, 12 over 3 is 4, and I have 4x over x plus 1.
I swear I put that in and it said it was wrong, so I must have entered it in wrong.
You've got 4x times the quantity x minus 1 over x plus 1. So I don't know where the x minus 1 came from. I don't know. Anyway, okay, who was the other one?
Number 6.
Number 6. Okay, and hang on. And again, the chapter review, right?
Yes,
Okay.
please.
Okay. So this is a chapter 7 review, number 6. It says find the perimeter and area of the LED screen of the camera. All right, so we've got a picture of a dog on a camera screen, and I'm just going to give you the information. We're told that the length of it is 4 over x plus 6 units, and the width or the height of it is 3 over x minus 1 unit. So those distances, okay? So the perimeter of a rectangle is 2 times the length plus 2 times the width. So the perimeter would be 2 times 4 over x plus 6 plus 2 times 3 over x minus 1. Okay. Now, we need to add those together. Let's see, 2 times 4, this is 8 over x plus 6, plus 2 times 3 is 6 over x minus 1. Okay. What's the least common denominator? X plus 6 times x minus 1. But here, even though I've written it as an equation, we really don't know what the perimeter is. So we just have to add these two fractions. This is what, x plus 6, x minus 1, x plus 6, x minus 1. So I'm going to multiply this by x minus 1 over x minus 1, and this by x plus 6 over x plus 6. So far, so good?
Yeah.
All right. So what am I going to get? I'm going to get 8x minus 8, 6x plus 36. So I'm going to get 8x minus 8 plus 6x plus 36 over the LCD, which is going to be 14x plus 28 over x plus 6 times x minus 1. So there's your perimeter. Okay. So I was adding two fractions with different denominators. I had to find the least common denominator, build each fraction to where it had a common denominator. Because we really didn't have an equation because we didn't know what the perimeter was. So we just had to combine them. You okay with that?
Yep.
Now, the second part, the area, we're going to multiply. So we're going to take 4 over x plus 6 times 3 over x minus 1. Nothing factors out and reduces, so we get 12 over x plus 6 times x minus 1, and that's going to be square units. And there you go. All right. Anything else? We're out of time, but I can stay if people need to.
For the 7.7 off the review, on question 10, I just don't know how to set it up properly. Because
Okay.
I got like a completely different answer than what I thought it would.
Just a minute. Let me find you.
Yeah, you're okay.
You're not in that class, so you're in the other one. Okay. So the 7.7 or the chapter review, which one?
The 7.7.
Okay, 7.7. Number 10.
Yeah, because it just says it goes slower than the plane. Because I got the question above it super easy. Like I figured it out, x plus 9, but I just didn't know how to really set that one up.
Okay.
For some reason, I don't know why. I'm
Okay.
just overthinking.
I'm going to draw my boxes here. So distance equals rate times time. And got a plane and a car. Plane, a car. All right, a plane can fly 330 miles. So the plane goes 330 miles in the same time. So the times are equal. The car can go 180 miles. If a car travels 60 miles an hour slower, so the plane is R, the car is R minus 60. Okay, so the plane travels 330 miles in the same time the car goes 180 miles. So the times are the same. The plane's distance 330 miles, car's distance 180 miles. You okay with that?
Yeah.
The car travels 60 miles per hour slower than the plane. So the plane is R, the car is R minus 60. Okay.
Okay.
So Distance equals rate times time, divide both sides by rate, time equals distance divided by rate. So this time is distance 330 over r. This one is 180 over r minus 60. So 330 over r equals 180 over r minus 60. Okay?
Okay, awesome.
Multiply both sides by r times r minus 60. R times r minus 60. The r's go away, the r minus 60s go away, and we've got 330r minus 330 times 60, which is 19800 equals 180r. We'll subtract 330r from both sides. So let's see here. 180 minus 330 is negative 150r. Then we'll divide both sides by negative 150. 0 divided by that. And we get 132. And it says find the speed of the plane. So that's 132 miles per hour.
Okay. I see what I did wrong. I had, I don't know why I did, but I did the 330 over r minus 60. So I kind of had them flopped, if that made sense. The fractions.
Yeah, so
Yeah.
these two were swapped.
Yeah, I had those
Yeah.
two flopped for some reason. I don't know why.
So yeah, because the car is being compared to the plane. So the plane is going to be your variable. The car is 60 miles an hour slower.
Okay,
All righty, we good to go?
I'm good.
Okay,
Thank you.
you're
Thank
welcome.
you so much.
I will be back this afternoon at 1:15. Should you have any other panic or whatever? Otherwise, have a good afternoon and don't forget to take your test tomorrow. And I'll see you all on Friday, if not before.
Have a good afternoon.
You too.
Bye.
Bye.